And now let me open the SPSS. So here we go with SPSS. So let me open any datasheet from its library. So I click the file and open then data. And now going to the C. In the C, the program files, and then IBM SPSS, statistics 20, and then samples English, and then from these library files we have here, so many files are available for the data analysis. So let me select this aflatoxin 20.save and then select and open. Now this is the data. So here we have two variables. One is the toxin and the other one is yield. See, our main study variable is toxin, whereas the yield is just indicating that these first 16 values belongs to the yield number 4 and the next 16 values belongs to yield number 8. So that variable is just indicating the specific yield. Otherwise, it has nothing to do with the analysis. You can see it's a demographic sort of variable or it's an indicator variable, just providing you the information that these sample values are related to the yield number 4 and next 16 values are related to the yield number 8. And now I'm directly going to the explore command in the SPSS, and for the explore you just go analyze, then descriptive statistics, and then explore. Once you click here, this type of the windows would appear. Is a dialog box to select the variables appropriately. So here our study variable is aflatoxin ppb, and this con yield is another variable which is an indicator variable that is indicating that the values are belonging to a specific yield, would be either 4 or 8. Now we will select our main study variable here and the indicator variable in case it is available, or the demographic variable if it is available, we will select here. Since this explore command is analyzing the data and it would explore the data and it will provide us all the descriptive measures which are graphic or measures type, such as different averages, different dispersion measures, or normality related different measures you can see from the explore command. So here you see I have just selected one variable here under the dependent list and another factor list. So keep in mind that under the dependent list we always select study variable, and in the factor list we select indicator variable if it is available. And now you see here both statistics and plots are calculated all together. And now after you select all the variables, just click this button which is OK. You see here. So the first of the table will provide you the information that under the yield number 4 we have 16 sample observations, and under the yield number 8 we have 16 observations, and there's no information as missing, so the total are also 16 because there's nothing as missing. And now we will move from one descriptive to the other. So here you see the very first descriptive is the mean. So you all know what is mean. Mean is calculated by adding all the values and dividing by the number of values. So in this explore output window you will see how many of the average related measures are available. You see one of the measure is mean, the other is mean, and then we have median. So 3 measures are available which are related to the average of the data, and you will see these are very closely related to each other, such as the mean is 14.68 and the prime mean is 14.65 and median is 14.5, etc. And then we have few measures which are related to the dispersion of the data. And these measures are standard deviation, range, and then interquartile range. There's a minimum value and a maximum value. Range is the difference between minimum and maximum. Interquartile range is difference between lower and upper quartiles. And then we have standard deviation here, variance. So in total, we have measures related to the dispersion. These are variance, standard deviation, range, and interquartile range. And then the question is, what is the significance of all these descriptive measures and how we will choose that which one is appropriate to the data, whether the median is suitable in this situation or the mean is suitable, which should be preferred, and what are the situation. And then few more descriptives here. We have tosses and skewness. These are different measures through which we judge whether our data is uh, compatible with the normality, whether it follows the normal distribution or it's away from the normal distribution. So you see here in the table, few values are related to the yield number 4, and the same pattern is there for the yield number 8. And the same descriptive measures are for the yield number 8 and yield number 4. And now explaining one by one separately. If we select all these measures which are related to the average of the data, these are mean, median, and trim mean. Mean is a very commonly used average and it's almost applicable in every case. But sometimes the mean is misleading in case our data are non-normal and has tailed, and particularly when we have few values on high value, extreme values on the upper tail, then the mean is misleading. The trim mean is basically calculated after trimming 5% of the observations from the data and then recalculate the mean, that is the trim mean. Interpreting how to calculate the trim mean. For example, we have 100 values and you trim 5% data from both tails and the remaining observations are 95. You recalculate the mean. That mean is called the trim mean. Once you take the difference between mean and the trim mean, it indicates whether there are few extreme values in the data or not. As you see here, the mean is 14.68 and trim mean is 14.65. So what is the difference between mean and the trim mean? The difference is only 0.03 or 0.02. So that is a very small difference. In case this difference is around 1 or greater than 1, then we can say that our data contain extreme values. Or maybe these extreme values can be outliers as well. But that is another story, that how to differentiate whether an extreme value is an outlier or not. That is another discussion. But while taking the difference between these two measures, the mean and the trim mean, if the difference is 1 or more, it's a clear indication that our data contains few extreme values. And then the next comparison is the mean and median. So the mean and median's comparison actually indicates the skewness in the data. If the mean is exactly equal to the median, it means there is a symmetry. The data are symmetrical. In case if the mean is greater than median, it indicates a positive skew. And if mean is less than median, it indicates a negative skew in the data. Negative skew means it has a longer tail to left hand side, and the positive skew means a longer tail to right hand side. So these comparison of mean, trend mean, and median from these three averages, we judge or determine whether the extreme values are lying in the data or what is the situation of the symmetry in the data.